Hey guys, today we're going to talk about angles formed by chords inside of a circle. So if we look here at our circle, we have two chords that intersect inside of the circle. Here's our first chord. Here's our second chord. Before we move on, I'm going to name these points. So let's call this first chord A, B. And let's call the second chord C, D. So what we have here are two chords that intersect inside of the circle. Along with the chords are the outside parts of the circle. The outside parts we know are called arcs. Arc AC and arc DB are formed by those intersecting chords. There's something special that happens with these arcs and the angle inside the circle. So let's add an X into our picture right here. If I wanted to figure out the measure of angle X, all I would have to do is add arc AC to arc DB, and then I would divide by 2, and that would give me X. So let's say that arc AC is 50 degrees, and that arc DB is 40 degrees. If I wanted to find out the measure of angle X, I would add 50 plus 40 and divide by 2. So let's do that over here. 50 plus 40, and I would divide by 2, and that would give me X. So 50 plus 40, so you might need to take your calculator out. 50 plus 40 gives us 90. 90 divided by 2 will give me X. So when I do 90 divided by 2 on my calculator, I get 45. So X equals 45. That means the measure of this angle inside here is 45 degrees. So to find out what X is, I need to add arc AC plus arc DB and then divide by 2. Sometimes the part that people forget is the divide by 2. They remember to add the arcs, but they forget to divide by 2. So make sure you remember to do that. Okay, let's take a look at our first example. We have to figure out what X is. We have our two chords. Arc PS and arc QR are the two arcs that we want to look at. So the formula says we have to add our two arcs and then divide by 2. So let's take 106 plus 174 and we divide by 2. 106 plus 174 gives us 280. So we have 280 divided by 2. Do everything step by step. 280 divided by 2 is 140. So X is 140 degrees. Two more. Same exact situation. Take your arcs, arc DC and arc AB. Add the two arcs, divide by 2. 190 plus 70 divided by 2. 190 plus 70 equals 260. 260 divided by 2 equals 130. So x equals 130 degrees. All right, let's take a look at number 2. We have to add our arcs. So we want to take arc AB and arc CD. 66 plus 70 divide by 2. 66 plus 70 gives us 136. Divided by 2, 136 divided by 2 gives us 68. So x equals 68. All right, let's turn the page. The second part of our lesson is going to be the measure of segments outside of a circle. So when I look at a problem like this, I sometimes refer to these as like the ice cream cone problems because it looks like an ice cream cone kind of on its side. So what we have here is we have a circle. And outside of our circle is point S. Point S now has 2 segments drawn to the circle. These are tangents. Remember, a tangent is a line that only touches a circle one time. This tangent touches a circle at R, and this tangent touches the circle at T. So this is a tangent, and this is a tangent. What's special here is if 2 segments from the same point, so 2 segments from the same point outside of the circle are tangent to the circle, then they are congruent. I'm going to bubble that they are congruent. All right, now you notice in our picture we have our tick marks, and we know what our tick marks mean. We know that these 2 pieces are congruent, which means they are equal to each other. So RS, segment RS, is congruent to segment ST. We know that means that they are equal to each other. All right, so if I told you that RS is 7, ST is 7. They're just equal. Let's take a look at our first example. So we're going to be doing a little bit of algebra in here, which is why we've been doing some algebra review in some of the lessons we've done previously. So let's take a look at number 1. First of all, to me it looks kind of like the ice cream cone. We have a circle. We have the 2 tangents drawn outside. So when I see a picture like that, I know that I can mark these off and say that these 2 are congruent to each other. Take a look at what they tell us. They tell us that AD is 2x plus 3. They tell us that AB is 11. Well, if I go right back up here, I know that they are equal to each other. That's the key word, they're equal. So all I have to do is set the 2 pieces equal to each other. 2x plus 3 equals 11. And it's our simple algebra problem. Let's get the 3 to the other side. Subtract 3. The 3's cancel out. 2x equals 11 minus 3 is 8. Divide by 2. 8 divided by 2 is 4. So x equals 4. That's all we had to do, find the value of x. Set equal to each other. All right, so let's take a look at the next two. All right, so we have the same situation here. Now, these are the ones that sometimes when they're so easy, people kind of forget what to do. They look at it and they're like, well, it's not exactly like the one we did right up above. It's not an algebra problem. Let's take a look at our picture. We know that we have a point outside. We have two tangents, so they are equal to each other. So this one should actually be almost ridiculously easy. If they are equal to each other, if this is 15, this is 15. X equals 15. No work involved, just understanding the concept. All right, so don't fall for that trick. When you see something as easy as this is 15, that's 15. All right, number 2 is similar to the one up here. We know that CB and AD are tangents, so they are equal to each other. Set them equal to each other. 3x plus 5 equals 14. All right, we got to get the 5 to the other side, so we subtract. The 5's cancel out. 3x equals 14 minus 5 is 9. Divide by 3. 3's cancel. X equals 9 divided by 3 is 3. And that's it.